Hello and welcome to today's webinar hosted by U.S. EPA. My name is Catherine Kazier and I'm a professional engineer who supports the Combined Sewer Overflow Program along with other wet weather programs for EPA's Office of Wastewater Management. This webinar is the second of a two-part series on smart sewer systems and smart data infrastructure. Smart sewers are sewer systems that use real-time monitoring, modeling, data processing and analytics, and artificial intelligence and machine learning to improve a collection system's ability to manage wet weather and other infrastructure challenges. Smart data infrastructure refers to technology, tools, and solutions focused on the collection, storage, and/or analysis of water-related data. Both webinars will highlight how communities have implemented these approaches to improve their sewer system management and decision-making. Before we get started, let's go over a few housekeeping items. Audio is available for this presentation through your computer's mic and speakers or by telephone. This webinar will be recorded and all attendees' microphones and cameras will be turned off during the presentation to preserve audio and visual quality. If you have a question during the presentation, please type it into the Q&A box. If you're experiencing any technical difficulties, please send a message through the chat box and we'll try to troubleshoot that issue. And lastly, so that we can better track attendance, questions, and comments, please rename yourself by finding our video box on the screen and clicking on the three dots in the upper right-hand corner. Select Rename and enter your full name. Please note that the views expressed in this presentation are those of the authors and do not necessarily represent the views or policies of the U.S. Environmental Protection Agency. Any mention of trade names, products, or services does not imply an endorsement by the U.S. government or the U.S. EPA. EPA does not endorse any commercial products, services, or enterprises. I also wanted to share with you all a few related efforts EPA is supporting. In addition to this webinar series, we are offering technical assistance to CSO permittees and state permitting authorities. Support is provided through our contractor, ERG. We are looking for communities to help us pilot several small CSO community spreadsheet-based tools, the CSO model, long-term control plan review checklist, and post-construction compliance monitoring checklist. We can also provide assistance for regulatory and compliance questions, troubleshooting operation and maintenance problems, asset management training, smart sewer and smart data infrastructure training, and monitoring and modeling training. Please see the technical assistance flyer in the chat box for more details. Earlier this year, in March, EPA also published a revised version of the Smart Data Infrastructure for Wet Weather Control and Decision Support document. This document was originally developed in August 2018 to share how municipalities, utilities, and related organizations can use advanced technologies and monitoring data to support both wet weather control and decision-making in real time, or near real time. The March 2021 version updates existing case studies with new information and added 11 new case studies. We included a link to the document on this slide. Please feel free to contact either Mohammed Bella or myself with any questions or new technologies you think we should highlight in future versions. Now on to our speakers. Our first speaker is Tim Braun, who will provide a brief introduction to smart sewer systems and smart data infrastructure. Tim serves Xylem's clients and teams around the world as a Senior Director, Global Enterprise Architect. For over 20 years, he has been an executive and clean tech entrepreneur with a focus on water and renewable energy technologies. Prior to Xylem, Tim served as CEO of Lucid Energy, entrepreneur in residence at Elevate Ventures, and most recently as Senior VP and Enterprise Architect at Mnet. Tim helped the team at Mnet gain a national presence leading up to the company's merger with Xylem in 2017. And with that, I will turn the microphone and the screen over to Tim.
Thank you, Catherine. All right. Good afternoon, and thanks again, everyone, for attending. I'm really excited for this session. Today, you're going to see similar themes from both communities, namely data-rich decision intelligence, starting with better utilization of existing infrastructure, then augmenting that infrastructure with new strategically placed control assets, and then discerning what remaining capital infrastructure will be required to get them across the goal line. So let's get started. Clean water utilities are seeing increasing intensity and frequency of wet weather events. This is not news to us, right? Meanwhile, expectations to perform are also increasing while financial resources remain constrained. And of course, we're balancing current operations and maintenance while planning future CIP, workforce challenges, shifting regulatory targets, and so on. In order to succeed across the board and do so affordably, we may want to rethink our approach. The current state, well, great news. Utilities have really stepped up their digital game. Many are gathering tons of data, improving data accuracy, doing advanced modeling of their infrastructure, and have implemented other IT tools as they move toward digital transformation. However, these data sets are often remainly large, untapped, or underutilized, or they're in disparate databases and locations, making them difficult to convert to actionable insight. Furthermore, many utilities have existing or recently added new assets with lots of opportunity for operational improvement. In order to get the most optimal performance from our collection systems, we need to connect the dots between gray, green, and IT infrastructure. So enter real-time decision support systems, or RTDSS for short. This is the common framework utilized by the utilities who are presenting in this series. RTDSS merge a myriad of data sources with continuously running real-time models. These data sources include sensor networks, rainfall forecasts, USGS data, and more. A symbiotic relationship between the data and the models emerges, whereby the models contextualize the data, while the data improve the models, forming a digital twin of the system. The computational engines in the digital twin continuously digest the many sources of input data to generate predictive analytics. Real-time decision support systems present situational awareness and actual insight and/or automated controls presented through user interfaces, graphic user interfaces in the bottom right. Perhaps most importantly, RTDSS benefit tremendously from the utility operator's own system knowledge and expertise as an active component of the framework, helping to achieve unprecedented system performance. So a great analogy to this is the modern smart car. As a driver, I can choose to drive with zero assistance, or I can turn on navigation for some situational awareness, or I can actually program my destination in for decision support. Or once comfortable, I can actually turn over automated control to the vehicle and focus my attention on something else, but remain in a position to jump in and take over at any time. So this is a typical RTDSS roadmap. The first step is often turning on the lights in the collection system, pulling in real-world data into the analytics and visualization tools. Next, we build live digital twins, as I mentioned, marrying the data sets with the models, which generates the foundation and ideation opportunities to then move to optimizing and operating the collection system as a globally optimal, coordinated control system, following the unique prioritized objectives of utility leadership and built on the foundation of assets already in place, weaving in future controllable assets as well. Real-time decision support goes way beyond inline storage, however. Tanks, tunnels, pump stations, gates, valves, high rate treatment facilities, stormwater basins, all can be integrated into dynamic conveyance and/or storage strategies. And yes, inline storage is one of those as well. Real-time decision support systems benefit from an open architecture framework, which is nearly always a unique configuration specific to each utility's existing investments in gray infrastructure and IT assets, including SCADA, historians, GIS, models, etc. What we see here is an example of a cloud-based optimization engine connected to the utility SCADA system to deliver predictive optimization for the management of gray infrastructure distributed throughout the collection system. It leverages the utility's investments to date and helps them unlock what's possible from infrastructure performance going forward. So future state. I want to go on record declaring that real-time decision support systems is the next big category in our industry. Similar to the categories of SCADA systems, hydraulic and hydrological modeling, GIS, etc., RTDSS will soon become the thing we look back on and attempt to recall, how did we live without it? Thanks to the communities who dove into this approach early on, we now benefit from their work to understand what is indeed possible. The industry is well beyond early adoption of real-time decision support systems, as you will see from these stories. These communities' efforts and good work will hopefully open the door to what's possible for you. I'll now hand it back to Catherine to introduce Stacia. Catherine?
Thanks, Tim. Let me get my slide up. Our next presenter is Stacia Eckenweiler. Stacia is an assistant administrator with the City of Columbus, Department of Public Utilities, Division of Sewer and Drains. She has been with the city since 2011, and during the bulk of this time was managing the design and construction of water and wastewater treatment capital improvement projects. She recently took on the role of assistant administrator and now oversees the city's 2 wastewater treatment plants, compost facility, and wastewater treatment engineering group. She worked for an engineering consulting firm for about 10 years prior to joining the city. She has a bachelor's degree in civil engineering from Ohio State University, is a registered professional engineer in the state of Ohio, and holds a Class 3 water supply operator certification in Ohio. Please take it away, Stacia.
Thank you. I'm going to go ahead and share my screen now. Okay, everybody see that?
That's good.
Looks good.
All right, thank you. Okay, as Catherine mentioned, I am Stacia Eckenweiler, and I'm with the City of Columbus, and I'm here to talk to you about Columbus's real-time control journey. Our system is fairly large, fairly complex, and interconnected, and this makes operational decision making very, very complex during wet weather events, and often just ended up in ineffective use of our assets as a whole. So our goal with real-time control was to give our operators better tools to use during wet weather events, to provide predictions and forecasts and things that they could use to make better decisions during those types of events. So a little bit about Columbus and our customers. The population of our city proper is about 900,000 people. Overall, citywide with our surrounding communities, we're just over about 2 million people. We are the largest city in the state of Ohio, and we are the state capital as well, and 14th largest city nationally, just to give you an idea of our size overall. Our direct customers, we have about 275,000 residential taps and just under 5,000 commercial taps. And we serve 24 contract communities of varying sizes all around Columbus. So we have an operating budget of about $300 million annually. We have about 2,800 miles of sanitary sewer, 1,800 miles of storm sewer, and about 167 miles of combined sewers, which are mainly, centered in our downtown area, as they are with most cities. We have 2 wastewater treatment plants. Our Jackson Pike wastewater treatment plant has a treatment capacity, full biological capacity of 150 million gallons a day. We probably see an average dry weather flow in the upper 60s. Southerly has a 330 million gallon per day flow treatment capacity, and I'd say their average dry weather flow is right around 100 or a little bit less. At Southerly, we recently added a chemically enhanced primary treatment train, which is an additional 110 MGD of wet weather flow. And I'm going to refer to this a few more times in the presentation as SEPT, just because it's easier than putting that whole mouthful out. So you're going to learn a little bit more about that process as well and how RTC has helped us run that process. We also have an ores tunnel, which is actually our first major effort here in the city to increase storage capacity and minimize our CSO discharges. It stands for the Olentangy Scioto Interceptor Sewer Augmentation. I'm sorry, even it's hard for me to even say Olentangy Scioto Interceptor Sewer Augmentation and Relief Sewer. So OARS or ORS, which I will also refer to a couple more times in this presentation, so I don't have to spit all that out. Which is a deep tunnel that's capable of storing about 65 million gallons of CSO capacity. We also have an interconnecting sewer between our two wastewater plants, which definitely presents operational challenges as to when and how to use the sewer and how to communicate on its use. And overall, actually, I'll just let you know, our earliest sewers were constructed around the mid 1800s, and some of them are still in use today. So these are just a couple figures to kind of give you an idea of the city of Columbus and our surrounding communities. The figure on the left, Columbus proper is essentially within the outer belt around the city. And our neighboring communities are the 24 communities that you see here, whose systems drain into our system ultimately for treatment. The figure in the middle is a map of our gravity sewers within Columbus and our contract communities, and some of our existing relief points are the red dots. The area in white right in the middle of the screen is our combined system in our downtown area. And then the figure on the right are just our two sewer sheds that drain to our two plants. The area in blue is the drainage area to our Jackson Pike wastewater treatment plant, which is located in our downtown, or just south of our downtown, kind of shown a little bit toward the bottom of the outer belt there. And it has the combined system that drains to it. And then the yellow and greenish area around the south and east part of the city drains to our Southerly wastewater treatment plant. So a little bit about Columbus's wet weather management plan journey. So back in 2005, we submitted our original wet weather management plan to comply with our consent order. So we were fortunate enough to get into our plan early on, and we actually had the opportunity to work with the Ohio EPA, which has helped with the implementation, the progression of our plan overall. Originally, it was a 40-year plan, and at that time, we had about 32 CSOs. The plan was going to eliminate the discharges to all but one location in a typical year and provide a 10-year level of service for the system overall. But back in 2012 and 2013, we asked for permission to allow us to reanalyze our plan to see if there was just a way that we could be doing things better. So in 2015, we actually submitted an integrated plan and an updated wet weather management plan. And that included 4 new aspects. So it was our Blueprint Columbus program, which included some green infrastructure and I&I reduction. Our ores sewer, so I don't have to spit all of that out again. And that was our CSO tunnel to provide 65 million gallons of additional capacity. Our chemically enhanced primary treatment process, or SEPT, which is at our Southerly wastewater treatment plant. And then of course, real-time control, which is what I'm here to talk to you about today. So since 2015 and the submission of that plan, this is just a graph that shows the number of activations, CSO activations overall in our system. So just a nice thing to see. You can see that our activations are trending down overall. Back in 2017, we put the ores tunnel into play, and that helped tremendously. And then we put SEPT into operation around 2019, which again helped. And we continue to make changes and improvements in our system overall in the way we operate it. So our real-time control journey began about 15 years ago when Columbus was reimagining how they were operating the gates at our largest CSO facility in the city. As it turns out, the actions at that facility were also a major factor in our largest SSO in the city. It still took us about 5 years to go from realizing this situation to implementing and automating the gate operations at this particular facility. So these two graphs are at our largest CSO, which we call DSR 83. And it requires careful management of our sewer levels and our regulator gates at a nearby structure to control what's going on with the CSO. So typically we would manually operate gates, and that would involve, closing gates to decrease the downstream sewer levels, basically in steps during wet weather events. This manual operation would result in overcorrection. It would be restricting the flow in the downstream sewer unnecessarily, and it wasn't the greatest way to operate this facility. So we put in automatic logic and controls on these regulator gates to allow for more frequent control and adjustment to maximize conveyance and treatment. And I know this is probably nothing new to anybody on the call today, but just one of those typical like aha moments where we can show how this all worked out. So what I'm showing here is an old graph on the left that shows that kind of incremental stepwise change in the gates and how it impacted the levels in our system overall. And then to the right, what I'm trying to show you there is once we implemented the automated controls, you could see that we had a nice smoother graph that actually was able to better control the gate positions, and then ultimately the subsequent downstream flows. And the red line that kind of runs right through the middle of the graph was our set point for the elevation in that particular facility. And you can see that we are right on it with the automatic controls. So this was kind of where it all started. And we thought, okay, time to start doing this elsewhere within our system. So, moving forward in our particular program, our goals were to introduce greater automation into our system and then also to evaluate real-time control decisions overall that could help us, find better ways to run other parts of our system. So our first pain point that we took a look at this point was the interconnecting sewer between our two wastewater treatment plants. So this graph overall shows that sewer straight down the middle of the page there. So Southerly is actually located at the southern end of that sewer and at the southern end of our system overall. Now they have an influent junction chamber that is located just upstream of the plant headworks. And I'm going to refer to this a couple more times in the presentation as well. I might call it the IJC, just so you're aware. And on most days, Southerly is providing treatment for the separately sewered east and southwest sides of our metro area. So at the top of this sewer, you'll see a couple structures. One is our Jackson Pike wastewater treatment plant, and that's near the center of the screen, and it treats flows from our combined sewer area in the downtown, and also some of our separate sewage from the northwestern part of the city as well. Now there is this 13-foot diameter sewer that connects the two plants, and of course we've cleverly named it the interconnecting sewer. And what it does is it allows JP to actually send flows down to Southerly during wet weather events. And this is managed by what you're going to see up there is the SMR gate. So our pain point here was that if you don't allow enough flow from Jackson Pike down to Southerly, then we end up increasing our combined sewer overflow volume within the system. If we let too much flow down the interconnecting sewer, then we can risk getting a plant bypass down at Southerly. So in big wet weather events, was there a Goldilocks setting that actually would give us just the right amount of flow that we would send down the sewer? So we ended up pulling in a fresh set of eyes to help us take a look at this. And that was, they were formerly called the MNet crew overall. Now they're Xylem, of course, Tim's company. And we turned this former operational logic completely around with their help. In the past, the plant operators would look at what is happening at the IJC, that junction chamber down at Southerly, and adjust how much flow was allowed to come down the interconnecting sewer. So operators were basically looking at the impact of a decision they made 2 hours ago back up in our system, in order to make a gate adjustment. So the impact of their change then wouldn't even be realized until 2 hours later. So imagine, the intuition, that mental model, and like all the safety factors that had to be required to prevent a plant bypass to make that decision to send more flow down. So our new approach uses several flow meters up in the system and a highly tuned real-time digital twin that was built using a swim model and other data analytics to forecast those future flow conditions. So this forecast is what provides our operators quantifiable guidance to maximize the treatment plant utilization. So, looking at our IJC prediction, I guess, is what you're going to see in this graph here. So this chart shows two predictions that we've actually crafted over the years through our RTC efforts, plotted against the actual observed IJC levels. So you can see those predictions are remarkably accurate based on the actual levels that we've seen in that particular structure. So the success of this first phase of our implementation with RTC is what helped us gain operator trust. And this is when our plant operators became truly engaged. They took ownership in guiding the next steps of our real-time decision support tools, and started coming up with ideas as to where we could implement this process elsewhere in our system. So our next big challenge that we looked to was that brand new SEP facility I mentioned previously that went into service in 2019, and was, we utilize it to provide peak wet weather treatment down at our Southerly plant. So, we could send more flow down to Southerly in order to utilize that treatment. But, we needed some time to get the process ready because, it's used only a handful of times a year. So, the plant staff told us overall, well, we need about 4 hours notice to make sure that this process is ready. So this was a good opportunity for us to take a look at RTC and how we could help them understand the best times to use this process. So that brings us to the next step that we put together, and that was our SEP prediction. So this was one of the tools that we developed to help them understand exactly when to run this process. And what you're looking at is an actual screen capture of our particular system used here in Columbus. It's designed to mimic the SCADA system in appearance, and that I think helps build trust with our plant overall, or with our plants. We want it to look like something that they're familiar with. And this was one of their decisions. This way, their operators at each of the facilities would have some familiarity with what they were looking at, which of course is going to lead to them using them more. And this screen can actually be displayed in real-time mode, or it actually has a historic mode where you can actually go back and look through past events and what everything in the system was doing, and get an idea of, what we do and how we adjust our system during wet weather events. But for this particular case, we're actually focusing on a May event that occurred previously this year. It was a great big rain event. And the right half of the screen you're looking at shows the schematic, and the chart at the top left hand, hopefully you can all see it, is actually configurable. Every numeric value that appears on the screen only requires a single mouse click, and then the data will actually appear up in the chart in the corner. The lower left-hand corner, basically the boxes of data there actually show the IJC prediction tools. So, where we think that our levels are going to be in that particular facility, and then also shows our SEP prediction tool that shows our operators when they should be ready to start SEP and when they should actually be starting it, along with several other existing, positions of existing gates in the system. So I'm going to walk you through just what our operators saw the day of that rain event. So on May 9th at about 1:45 in the afternoon, had already been experiencing rain for several hours, and the low warning turned on for SEPT, which is in the box in the left-hand corner. It's a little orange word there. It says low. And at this point, our 65 million gallon Oars tunnel was just starting to fill up. Jackson Pike was actually running at its peak rate, and Southerly was only using about 75% of their capacity. So we moved forward to about 3:30, and the SEPT activation warning went into high mode, meaning the prediction was near certain that we were going to have to run this facility. So at that time, both the plants were at their max secondary capacity, but our Oars tunnel still wasn't utilized. So we still had space. We still had a little bit of wiggle room. At about 5:30, Southerly ended up turning on the SEP process, and it was about 3 hours and 50 minutes after the very first warning, it's a 4-hour prediction tool, so it was pretty spot on. And the plant were able to activate SEPT in accordance with their operating procedure. Our real-time control decision network here helped allow the plant staff to respond, to prepare, to be ready for this. And it provided the information to the operators so they can understand all the dynamics at play and respond to the event by maximizing treatment and deploying this new process on time. So, zooming out, this is just, kind of the end capture of that particular event. It lasted for about 5 days. It was a pretty significant rain event. And you can see, everything on the screen is pretty much full at this point. So everything was running, everything was at peak capacity. And you can see the yellow boxes on the chart. That's basically what's showing that. JP is in blue. It ran for about 3.5 days at their peak capacity. And Southerly, if you look at the corner, the box up in the corner, there's a bunch of lines through here. So the blue line is JP running at peak capacity for several days. The black line along the bottom is actually the SEP process. So you can see where it kind of got turned down. We put one clarifier into operation, then the other one, and it actually only ran for about a day. But our plants were maxed out for, several days and a lot longer than this. So, even the Southerly plant capacity, which is shown in green, was still trending above dry weather flow for several days after this event. But what I really want to point out here is the orange line, which is the level in our Oars tunnel. So SEP dropped down to about 50% capacity after only 13 hours of use, and it shuts off fully while our Oars tunnel is still full. So, we often have the debate of whether or not we should dewater the tunnel using our wet weather treatment, the SEP facility, or not. It's not preferred because it's not full treatment. It's only chemically enhanced primary treatment, which means we, coagulate our primary clarifiers, and then we actually send it through disinfection and dechlorination. So, we struggle with how do we get the most treatment out of our system? And using this RTC, this decision-making tool, we were able to actually only run SEPT as long as we needed to, and then turn it off and actually treat the rest of those combined sewer stored flows through full biological treatment at our plants. So, this is pretty big for us, because this goes to show that, we know just how long that we have to use our SEP process, and when we can turn it off and actually continue to treat the rest of the flows in our tunnel through full treatment. And this kind of tool and this type of decision-making process could probably, might be the only way that we know for certain that we only want to use our SEP blending process and only use it exactly when it is necessary. So that actually showed us overall that this was another great tool for us that, got developed through this process, and actually, gave us confidence and gave the operators confidence that this process works. And, there are still better ways that we could be using it and other things we can be implementing. So overall, our technical achievements, we've seen, a reduction in our system-wide overflow for sure. It's kind of hard to quantify exactly how much that we can attribute directly to RTC, just because we have so many other moving parts in our system, but we do continue to analyze the data. It showed us that we can confidently use our SEP process only when needed. And more importantly, we can even have that information readily to prove that to others if we needed to. We did identify some weaknesses in our sensor network. There were some sensors that would drop out during key times. And so we've addressed those by adding backup sensors, to make sure that we had the predictions and all the data we needed when we needed it. And we just continue to seek opportunities for improvements overall. And then when it comes to organizational achievements and how we made this work, within the city and within all of the various sections that are involved in, working with this process overall, one of the biggest ones that I think is that our plant staff now own our solutions, and they are helping us lead the process. We've had success with addressing these pain points, and it's helped us build trust and enthusiasm within our staff. And actually, just recently, our plant staff had recommended our real-time control decision-making system to our sewer maintenance staff, and those staff are actually responsible for maintaining our flood wall. We do have a flood wall here in the city that requires incremental, stepwise process to happen during, certain wet weather events. So this is a perfect opportunity to utilize RTC as well. And we're actually getting started on that particular task as well. And then huge improvement overall with coordination between our two plants. Now we can see everything in the same place. Any one of us could log into it and see what's going on in the system. It encourages our plants to have, the big picture of what's going on everywhere. And to talk with one another during these types of events. Our operational staff and engineering staff and leadership, continue to be informed and engaged, throughout this whole process, and we all work together to try and further optimize our operations. And we have our consultants on board, Xylem in particular, that are helping us and supporting the system optimization, and we've been communicating as well with our modeling groups and those consultants that monitor our SCADA system and upgrades, and even future planning efforts overall. So it really has helped us become a real consistent team working together, and RTC is something that pops into all of our mindsets as we move forward with new projects overall. So I guess my advice too for anybody who's considering RTC, form the right team early on. We started this as an engineering project, but it migrated into our operations group and an operational led approach, and that helped a lot. You don't want it to be somebody sitting in an office putting together a project for you. You need to have your buy-in with your operational staff from day one. And just begin with that study to address, that single pain point. Just bite off, just enough that you can chew, and then you can consider a broader study to continue to form that business case overall. And if you need to, grab a fresh set of eyes and pull in, a different perspective, like we did. That definitely helped us and got us to where we needed to be. And don't overanalyze either. As they say, perfection is the enemy of progress. So don't get stuck in that analysis paralysis, because we've been there a couple times as well. So yeah, leverage your existing systems, and that will help build trust overall, and you'll be able to move into the next steps. So I believe that brings me to the end of my slide overall. Here's my contact information. Feel free to reach out to me if you have any questions. I'd be happy to talk to you a little bit more about our journey and share any insight I might have. So with that, I am going to stop sharing my screen and pass it along to the next presenter, OJ. Well, actually, I think back to Catherine.
Yeah, I'll introduce OJ first. Thanks. Nice presentation. Thank you. And our next presenter is OJ McFoy of the Buffalo, New York Sewer Authority. OJ is a passionate public servant and water sector executive with over 2 decades of leadership in advancing innovative strategies, delivering large-scale, multi-million-dollar comprehensive plans and capital projects, and expanding equitable public health policies. A native of Buffalo, New York, OJ was educated in the Buffalo public school system and is a 1993 graduate of Hutchinson Central Technical High School. OJ earned a Bachelor of Science degree in Civil Engineering from Clarkson University and a certificate in Executive Management from the University at Buffalo. He is also a licensed professional engineer in the state of New York. OJ resides in the Willard Park neighborhood in Buffalo, New York, with his wife, Monica, and 3 daughters, and considers himself to be a die-hard Buffalo Bills fan. Notice the pin on his shirt. I'll now turn the microphone over to OJ.
Thank you very much, Catherine. So I'll just get started with our system. Again, Stacia, thank you very much also, and Tim for kicking us off. And Stacia really drilled down into the utilization of real-time control as it relates to large tunnel systems, as well as treatment facilities, and including our SEP. Where I'd like to take it is a little different place. I always start off here at the city of Buffalo. We are a recovering transitional post-industrial city. And, for us, we try and keep it, really simple, really humble. We're a little hurt last night from the loss we took by the Bills, but we'll be back at it again. So remind people, normally this is the slide that we use for our folks down in downstate New York City, but just the location-wise where Buffalo sits. Buffalo sits, of course, in the Great Lakes watershed, just some of the best places to live in America. And it's some of the freshest clean water that we have the privilege of being on the banks and shores of. We sit at the end of the Lake Erie and right on the shores of the Niagara River that, of course, goes over the famed Niagara Falls. And you look at where Buffalo sits, and going with Buffalo's history, we have a long history of being part of the expansion westward, as we were the gateway or the end place of the famed Erie Canal. City of Buffalo sewer system, while we are a city entity, we are really a regional entity, and we take in flows from many of the suburban communities. We were established in 1935 as an effort mainly because of the complaints from Canada and the pollutants that were being placed into the Niagara River. We were actually established by the state of New York as a public authority, and within that we have many of the rights and privileges of different organizations, not just as a municipal entity, but we have some larger pieces that go along with us. And with that is to receive flows from outside of our districts. So we have a service area of about 550,000 people. Around 270,000 of those reside within the city of Buffalo. We have a coverage of about 110 square miles locally with our collection system. It's about 850 miles of pipe with an annual budget of 60 million and a capital budget of roughly 20 to 25 million. In 2014, we were able to get our long-term control plan accepted by the regulators, and that is going to take us from 91% capture to 97% capture. And just giving you a little bit more about our city of Buffalo. In 1900, Buffalo was the 8th largest city in America. And what we did was we built our infrastructure to reflect our growth. If you look at that line there and it's heading straight up, we thought we were going to be at 1 million people, and we put in enough infrastructure that will reflect that. So whether it's our roads or whether it's our underground out of sight built infrastructure, we conceived it with the possibility of a city that was going to grow to 1 million plus people. Now that is a good thing and a bad thing, because now what we're left with is it says 261,000 in 2010. We just recently got our latest, and for the first time in 50 years, Buffalo has actually seen an increase in population, and we've reached 272,000, which is a great thing for us. We are on our comeback, but we are still nowhere near the 573 that we were at our peak, nor the 1 million that we were planning to be. So we have a significant amount of infrastructure that is buried. We have a significant sizing of infrastructure throughout our city that was buried. And as we note here, in our evaluation period, we have over 8 major trunk lines that were half empty during peak storms during our typical year when we were looking at this from a design standpoint. But really, we also have just some systemic concerns throughout the city of Buffalo. Buffalo has a plus 30% poverty rate, and that's reflective across our city. So what these maps show is how hard the poverty has hit our city. As we are a post-industrial city, industry vacated us, more than 50 years ago, and we are just now getting into a groove of recovery. And then the pandemic came along to kind of knock us back a few steps, but we're back at it again. But we keep that in mind, in that we know that we have some systemic concerns throughout our city, and we know that we have some built environment concerns in some underserved areas, some EJ areas. So when we look at how we are going to address water quality concerns and environmental concerns, we really take a concerted effort to make sure that we are not only dealing with the environmental concerns, but that we are helping to correct some of the systemic deficiencies within our city. So the Buffalo Sewer Authority's Smart Sewer program, we have a number of objectives, right? First being, of course, 9 minimum BMPs, maximize the use of our collection system storage, right? Identify additional opportunities, and always continuous system improvements. Now, our plan was developed a number of years ago. In 2004, we put to the regulators a plan, and it had a preferred, it had a recommended cost of $524 million. And for a city like Buffalo with a 30% poverty rate, that simply was unachievable. And so what we put forward was a preferred plan for delivery and solving some of our water quality issues of $167 million. And of course, a couple years later, they came back and said, no, that's not good enough. So in 2006, we started on a new journey to look and see how we could address some of our wet weather concerns that were causing combined sewer overflows and water quality concerns in our lakes, streams, and rivers. Which brings us up to the dates in 2008. We were aware of a couple of companies that were out there that were really doing some innovative things. And we had an RFP, we went out to them and we said, hey, we have a very robust system. Much of our system, as you saw in the previous couple of slides, is aged out. We have a significant amount of sewers that were put in the 50s to address water quality concerns. We ended up twinning and putting in system storage and static storage and some static weirs. So we have a lot of infrastructure in the ground. We want you guys, here's our swim model, and here are some other tools that we have. Here are our flows. Take a look at our system. What can be done from an innovative standpoint as it relates to censoring smart sewers and utilizing data acquisition throughout a collection system that will help us bridge this gap of a lack of resources that a city such as Buffalo has with a 30% poverty rate, to make sure that we address water quality concerns as efficiently as possible. So in 2010, we got the reports back from the two companies, and we sat down, and they were very similar, slight differences in each of them. But one company's cost of fees was $1 million cheaper. So imagine, we looked at them, we went back to the other company and said, hey, you want to adjust your fees? They were like, no, we believe our fees are good. So Buffalo made its decision to go with the company. At the time, his name was MNet, now Xylem. But we partnered with them in really, handing them the keys to say, hey, listen, how can we be efficient? We understand about, inputting great infrastructure and deep tunnel systems and wastewater treatment facility improvements. But we want to look at our collection system first as the primary piece in the solutions to be efficient here in the city of Buffalo. And with that, we had developed 16 locations where we were going to install real-time control projects that were recommended with our first blush at our system. And with that, we put in our first two in 2014. And those were located in two areas of our city, two different areas on two different trunks, one in Bird Avenue trunk and one over in our Lang Avenue in an EJ area. And those were our first demonstration projects, and amazingly successful when they were finally constructed and went into post-construction monitoring in 2016. But it really gets to when we identified those smart sewer locations where we were going to put in those real-time control plans. Between that and the real the green infrastructure funds that we were looking at, we were able to reduce the cost of our long-term control plan solutions for addressing combined sewer overflows to $380 million in 2012 dollars. So we were able to save a significant amount of money, which for us is the reason why we come back to this. For cities that are struggling, and we all are struggling with the cost of many of these improvements to address water quality, we have to be aware, we have to bridge that gap of a lack of resources with innovation. And that's the journey that we've been trying to go through here within Buffalo. So right now, we currently have six. We just got the last two in the ground. Our real-time control plan, they are in the ground, and they are in post-construction monitoring. Some of them are in the fine-tuning phases, but we project out that we will be adding another 6 to 8 of them throughout, because we've now had to redo our model and find out, through an iterative process, which ones are going to be the most effective. And some of the ones that we had anticipated doing in 2010, we're now looking at and saying, well, things have kind of changed. So as an iterative process, now, hey, you know what? This one would be a great opportunity to do. So this is what we have been at it. But really, the foundation was established when we put in our Bird Avenue and our Lang Avenue sites. And this right here is just a really a reflection of what happens at our initial sites. Very, very simple, very clean designs. They are all inline storage. And when we're looking at downstream versus gate position and upstream level versus gate position, and I'll just take for you right now a view of it in this graphic. So you can notice the water levels as the gates come down and they throttle. You will notice the water level that backs up in the chamber. It's also backing up along the pipeline, which is giving us significant storage at this location, as well along the pipe system there in the interceptor. So this is huge for us. So we have a number of locations throughout our city. One of the things that we did, this segment of sewer, of course, was late 1800 vintage. And we wanted to make sure that everything was okay, but we definitely were surprised when we got in there and found that everything was in good shape and it needed not that much detail. So also, as we're putting in these projects, one thing that we've come to learn is simple is best for us. We want to make sure that we are designing and implementing robust systems with the redundancies, with the fail safes. Because that's always our biggest problem. It does us no good if we put in these great innovative systems and we end up with basement backups, right? The court of public opinion, we're doomed. So one of the things that we really have been focusing in on, especially some of our larger ones, our more high profile ones, as in this location, this chamber here in North Bailey is one of our principal arterials. And it sat right in the middle of a major bus route. is we want to make sure that when the gates fail, or if the sensors are out of range, or the PLC logic, we have redundancy for all of those things. When we also have automatic reset and things of that nature, to make sure that nothing is left out. We take a belts and suspenders approach to everything that we do, and it's been very successful for us. But what also has been successful is the money saved, but also the volume and the CSOs prevented, excuse me. And in this video, you can see just how the functionality works when we put in the coordinated real-time control. We had a site, the initial site at Lang. We had a partner site that was at Hazelwood that was also installed, that allows us to use both of them in a coordinated fashion to maximize capture in preventing combined sewer overflows. So you'll notice there, Lang activates first, and then we get the storage coming at Hazelwood. And then as the storm subsides, we then start throttling the gates to allow that flow to go back into the Scajaquada interceptor, first with Hazelwood and then slowly with Lang, and allowing that water to come back in a predictable fashion to the wastewater treatment facility. One of our largest sites here you'll see is our Hurdle Deer, which this is a picture of the construction. It ended up being a 3-story circular piece where we went down, and just because of some utilities and in the manner in which we had to say it. But we have a number of sites throughout our city. The Hurdle Deer sits at the northern portion of our city, in our North District. And we also have locations, again, within the central portion of our city, which we call our Scajaquada district, and in the south portion, which is our South Central district. In design, we also have a number that are going to be down here in our South Central portion, one in kind of our downtown corridor, and one in an area of our city that is kind of up and coming. So one of the things I want to share with you briefly is this is how it is. We put in the belts and suspenders. So not only do we have belt suspenders, we put in, chaps, I guess, some other things to hold up your pants. We want to make sure that if everything fails, even though we have designed it not to, that flows continue to move through. So what we have for all of these is side weirs that can continue to carry the flows of the entire size pipe. So what you noticed in that second video was really the weir overflow point that goes around the gates that, again, is part of our belt suspenders and another set of belts and to make it happen. And here is the effectiveness of our program as it relates to our real-time control points. And this is simply just for our Bird, our Lang, our Hazelwood, Hurdle Deer, and North Bailey. We've excluded Smith because we start getting into areas where we get some backflow. So we don't want to confuse the issue of success with treating river water, but we have solutions for that. But if you look at it, Bird and Lang were commissioned early, and you look at our success here, and then again the coordinated flow of Hazelwood that came into play. And if you look, you'll see the overflow volume and the capture, and then you'll see the 3-story one that we talked about, that with Hurdle and Deer coming on board, and then in North Bailey, you just see the increase in the amount of system volume captured during wet weather. And this for us is amazing. These real-time control, utilizing existing system and simply putting in a box for control with all of the smart techniques that are involved and the data analysis that comes with it, have been the best price per gallon of any of the combined, the CSO dollars that we have been spending. So what are our next steps? Again, here's another picture of Hurdle Deer. We're so proud of that location. But right now, we have commissioned another full sensor deployment throughout our 850 miles of collection system, 90% of which is combined. We have a full sensor out, so we are going to be censoring over 200 locations. We call them, near our traffic cops or our sewer patrol points, which are those decision pieces within our system where it decides if it's going to continue to flow or if it's going to overflow into interceptors. We're also focusing in on empowering our operations division and really improving the predictive maintenance of all of the facilities, including the sensors. We want to make sure that they are quite robust, they are simple, and they are effective. And our goal is to complete the remaining real-time control sites by 2024, and then augment that operating system with artificial intelligence kind of embedded in establishing boundary conditions and truly expanding that coordinated control, similar to what we've done at our Hazelwood and our Lang sites. We have that opportunity to do that at a number of sites throughout the city of Buffalo, and we want to continue there. And again, our reasons for doing it, our why, is it's been very cost effective. We can really get down into, what type of sensors and all the rest of those things, and that becomes part of the design. But the effectiveness of taking this approach, this smart data, this smart aspect of approach, and realizing, whether it's the decision support, but the understanding and of what your system is capable of doing. If only it had a couple of valves, if only it had a couple of gates in it that could throttle flows coming to your treatment facility. Even when your treatment facility is as large as ours, we have a treatment facility that has a 120 MGD average daily flow. We got a capacity of 563 million gallons a day during wet weather. We're the second largest treatment facility in the state of New York, but wet weather doesn't care about that. You have to be able to utilize here in Buffalo the 850 miles of sewer pipes that we have to make sure that we throttle those flows, we allow them to come in, we smooth out the humps in our hydroflow graphs, and that we're effective with the use of our money. And with that, I thank you very much for the opportunity, and here is my information. I'm going to turn this over to Catherine so that we can get into the Q&A session. Thank you.
Thank you very much, OJ. Thank you to all the speakers for a great presentation. Now, with the remaining time, we'll respond to the questions we received in the Q&A, which I think as of right now isn't any. So I did want to let the audience know that we are going till 2:30. So if you do have questions, please put them in the chat. We have some additional questions that we can ask, but we would prefer to answer your questions first. So for the Q&A session, I'm going to have Jake Albright of PG Environmental moderate the panel discussion. Jake has worked in the wastewater sector for 15 years. Over the past 10 years, he has supported federal and state agencies in evaluating dozens of wastewater utilities and collection systems across the U.S. Jake brings a national perspective on how wastewater utilities of all sizes, faced with differing challenges, manage and implement their programs. So I'll say, take it away, Jake, but maybe first I'll interject that in the chat box, I did put in the link where we'll be posting the recorded webinar. So we'll have the recorded webinar there, the flyer for the webinar, and the slides. So be sure to check that out. If you didn't see it in the chat, you can always Google EPA CSO, and you should be able to find it. With that, I think all of our panelists will have their videos on, and Jake will start the Q&A.
Thanks a lot, Catherine. Yeah, like Catherine said, if you've got questions throughout the process, feel free to put that in the Q&A box. Otherwise, we'll kind of go through the facilitated discussion here. I've got a few topics here to go through with our panelists. So yeah, let's just jump into it. On occasion with these, advancements in technology, operators might see this as a potential threat to their job, automating operations, advancing what technology can do versus what can be done manually. Stacia, I'll start with you. In your presentation, you talked about, you creating that buy-in with your operators by alleviating some of their pain points. Did you experience any hesitancy from your field personnel or your operators in embracing this from the start, or was it kind of a go from the jump?
Well, I'd say, from the start, I made just a real brief mention of it. The project started out in a different light. It started out as an engineering effort in one of our engineering groups. And, those projects can sometimes, fall into that kind of that vacuum mentality where, it really just is an office engineering problem. And, we come up with solutions that are, just identified from modeling and internal discussions overall. And I think that was, we set ourselves up to not get the buy-in that we needed from our operations staff just by doing that. We got smarter later and we pulled our operations staff in and actually, made them part of the discussion and talked to them about what it was that they wanted to see and what were the things that they wanted to accomplish. I think that when it comes to, the system operation as a whole and the fact that before we were doing this, everything was, an operator decision or the decision of multiple operators, there's a lot of pressure with that because if you make a decision, to change something in the system and then flow goes one way, not the other, and we have a bypass, or an overflow or something, that is either regulated or not, or even a permit violation, that puts a lot of pressure on our operators, and that's, just having them make a personal decision is, some of them will view that as a little bit risky too, especially now that we have these tools in place. So, what they want us to do is help them create the data and show them, what we can be doing and then how we can back up those decisions with the data that we're gathering in the system overall. And I think that helps, provide a little bit of comfort too. We have verifiable conditions and data we can look back on and actually, talk about why we made decisions or how we can make decisions better and ensure that we improve upon those in the future.
And just
ultimately
really,
has,
sorry,
go ahead, OJ.
I was just going to follow up on what Stacia was saying. Really just to piggyback on that. If we had something to do over, that would be it. One of the things that we did when we went about this is we didn't include our operations staff, right? It was going to be like, this is a black box, do not touch. And that was the worst thing we absolutely could have done. And, Stacia had mentioned operator trust and kind of owning this solution. That has been something that we have been working to improve upon ever since the first ones went in there, right? We make sure that we have an aggressive training plan. We make sure that they understand now, hey, this looks just like one of your SCADA screens, here it is. But if we were to do it over again, we would have made sure that the folks who are going to be responsible for it and operating or were part of the discussion, were part of the change framework as it was being delivered, and not just a bunch of us engineers in suits kind of coming together for that solution to save the world.
Yeah. And I guess for both of you, I mean, is this something that's helped optimize your staff's time to be spent, doing more, proactive or preventive type activities versus putting out fires? Has this been kind of a, an optimization of time resources?
From Columbus's standpoint, yes, and I'll point back to that the SEPT optimization tool that we put into play. It takes a lot of time to get that chemically enhanced primary treatment process ramped up, so it's like the last thing we want to do is have our staff who, of course is going to be during off hours and, middle of the night and we're already down to bare bones staff at those times to begin with. We don't want them to have to focus their time on readying the system if there's a chance that it might not even be used or we fill one of the tanks and really that's all we're going to do. So from that standpoint, yes, it has helped us learn how to optimize our assets and focus our attention on the assets that we need to when we need to, and leave the others lie if they're not going to come and play for that particular event.
This is an area that we're very hopeful for. This is why we're moving forward with our full censoring of our complete system of 850 miles. We are expecting out of that to give us not only notification of when there is siltation in many of our pipes and when it's time to get out there, so that right now, our program is we kind of follow the city where they're going to be doing projects. We're doing the projects. We, as far as asset management, we make sure we get a certain percentage clean and CCTV. But to have a predictive tool that is always there, always on, providing us data for, hey, you need to get out and address this. That's something that we're looking forward to, and we know that it's going to make us more efficient.
Great. I'm going to divert here to some of the questions from the audience. OJ, you just talked about using this as an indicator for asset management and cleaning of the pipelines. Are you running into any sedimentation issues in the pipes after these storage events in particular?
No, that's an excellent question. One of the things that we put into the design features of it is the modulating of the gates to make sure that we're keeping the continuous velocity going through them. So it's never, ever just stopped and, just fully stored. There's always velocity. There's always things coming out of it. But with that said, while we're not seeing it necessarily in the pipe, there you still have to do the maintenance, especially along the side weir in different areas where you got to get your vac trucks out there and maintain them just like you would anything else throughout your system. So it's not been a problem, but we've made sure we stayed on top of it.
Okay, great. And then Station.
Jake, if I can just tag on there. What's one of the interesting things that went into the design of the gates in Buffalo is that the gates actually take turn one storm event to the next. And so if gate 1 is all the way closed in one storm, gate 2 is modulating, letting flow through, and the next storm, gate 2 will come down and gate 1 will modulate. And that helps keep the gates cycling with each event, and B, ensures that, as OJ mentioned, the flow is always going through. And the gates actually also cycle. So if we have quite a few weeks of dry weather, they actually will automatically cycle to make sure everything's operational between wet weather events.
Great, thanks, Tim. Stacia, another one that's come in here for you is you mentioned that these controls have been implemented in the MS4 as well. Is that accurate? And I guess if so, how are you using them?
No, actually, I saw that question too. At this point, we're only utilizing them on our combined system, so our sanitary and storm combined system overall. So we haven't discussed using them in our stormwater system yet, but it is something that might come down the road.
Great. And then I've got 2 questions here about cybersecurity and data management. I guess I'll stick with you, Stacia. I guess, is that something that you are heavily involved in? Is that something you are working in coordination with Tim and Xylem on? I guess, how is the data security management handled?
Yeah, so I don't have the background and experience to talk about this in any great detail, but I know that the way that we've set up our network overall to show the data that's on the screens, there are multiple layers of security, multiple clouds that we work out of, so we don't have any direct connections to our SCADA from our SCADA system, to the cloud or any any sort of accessible network that outsiders can actually get into. So we have taken those necessary steps because we definitely recognize that none of our system overall is actually accessible remotely. Everything is accessible through our MetroNet system, and our facilities and our operation of our plants only talk via internal network, and we don't have any remote access overall.
That's an excellent question. I think cybersecurity is first and foremost on everyone's mind nowadays. Especially during this pandemic, as far as just hopping on and grabbing a Word document from home. Those are the things that we're looking at. But now we come in and we find instances of hackers coming in and controlling facilities, controlling wastewater facilities, producing dangerous situations. Us, like Stacia in Columbus, our entire SCADA system sits on an island without any controls from remote access. You do have to be, present in there, plugged in to get access to that. With our real-time controls, they are on a cloud system, and we have all of the different layers of control associated with those as well. I don't know if Tim wants to chime in with that on their side, but we make sure that we're covered, along with insurance and along with everything else, and dual authentication and everything that we try to keep ahead of potential hackers of invading.
I'll just mention in general, with each system, I mentioned during the opening comments, the open architecture approach. We work with each client to make sure the systems are in compliance with their IT departments and specific cybersecurity requirements. We also do outside cybersecurity work as well to make sure that our systems are as tight as possible. But yeah, just in general, this is obviously very front of mind for us as well, and taking all measures as appropriate.
Great, thanks. Then Stacia, you talked about obviously your kind of digital footprint and the way that things talk to each other in your system are very interconnected between the collection system and the treatment plants. Is that all one integrated kind of contiguous SCADA system, or is it two separate SCADA systems that are talking to each other? How does that relationship work?
So the plants themselves are on their own unique isolated systems, and our assets that are out in the system, they actually, well, at least as part of real-time control, they are not configured into our SCADA system overall. So the screens that I was showing that show, some of the flow meters and level sensors and things like that, they are operating on a separate platform, and we're pulling data into a separate platform that does not connect with our plants overall. So it does require operators to kind of look at two different screens during events, and of course the more important one is going to be the plant one that they're viewing. But we recognize that we cannot put those all in a single location because we don't want to have those outside connections. The RTC website that we utilize is web-based, so we do need authentication to gain access to the site, but it's up on the web, so by that virtue is potentially unsecure. So we have no direct connection between that and our SCADA system.
Same for you, OJ. Yeah, she said the same thing. Ours is very similarly designed. It is one of those things where, had we to do it over, even if we had two monitors, at least they'd be next to each other, as opposed to this monitor being a little further away. We wanted to make sure that it is in their face, and we've been doing that, over the past several. To make sure that we kind of solve that solution and get that buy-in from all of our operators. We need to understand, right? It's not just the alarms that are popping up for, things turning red or what have you. Like, own this working with our collection system folks, because, really, and I don't know how everyone else's treatment facilities are, but, we have those division lines, right? Thou shalt not cross into collections if you are on the treatment facility side. And what we've been trying to do really has been to integrate those and to say, no, listen, guys, everything is connected and we all have to work together. So, that's been an ongoing effort for us.
Right, and I'll jump in to clarify one more thing too. So our system is not yet automated. Our system offers predictions and forecasts and tools for our operators, but the ultimate changes or activations in the system those decisions do still rely with our operators, or rely on our operators, or lie with our operators. So we are likely trending toward an automated type system, and this is definitely going to be something that we're going to have to think very intuitively and cautiously about in order to make sure that we are addressing all of these concerns. And we do have all of the necessary controls in place when we need our system to talk with our plants and potentially even operate them.
Right. So I guess with that in mind, the concepts and operations aren't necessarily new or groundbreaking necessarily. It's just kind of the way that the system's been designed now and automated. What kind of a learning curve has there been for your operators? What kind of guidance are you giving them to make those decisions with the kind of the new types of information they're getting?
Stacey, you want to touch that one? For ours, it's still automated. That was one of the things that we implemented initially was, it is automated. It's queuing off of the sensors and it's happening. One of the things that we want to move it a little bit towards is, that information gathering and getting them to kind of own it. So, Stacia, you guys have a kind of a different procedures, I think where we erred is we told them it was a black box, don't touch it, and so stay away. But that means it was fully automated. Right. And I wish we could slide that over a little bit more. So again, if we had it to do over, I would slide it over. But it is fully automated.
Well, and so, us being on the other end of that spectrum, we are at a point in our efforts here. Yeah, we're trying to push ourselves toward the middle and we're having, it's not, it's been ongoing discussions with our staff because all of these recommendations are just that, they're recommendations, and our operators can choose or not choose to use them. So, our big step or next step in the program is to, try to figure out, okay, if you didn't do X during this event, why? Was there a reason? And if there is a reason, let's talk about it. And then we also are looking to do some data gathering and analysis that shows like, okay, so here's what we did during this event. If we would have done this, this is what the model shows, so let's see what goes on with reality versus, perceived or proposed reality and try and hone in on, why we should or shouldn't be doing these things, or, should we be following the recommendations? Were they correct? Or, would something have been wrong? Because we still do have, that intuition from a lot of our operators that's like, well, I've been doing it for years. I've been doing it this way. And, I don't want some computer to tell me what to do, right? But if we can show them what the results would have been if they would have listened or taken the recommendation from the system, then that's just our next step to trying to build that buy-in with the process. So it's a lot of data analysis. It's a lot of comparison. It's a lot to go through. And I know a lot of people end up, kind of getting that deer in headlights look after you go through so much data, but that's what we're doing here, right? We're gathering a ton of data and we're showing what works and what doesn't work and utilizing that to continue to gain that operator buy-in.
Yeah, Jake, I mean, really, it's part of change theory, right? I mean, it's an ongoing piece there because, we know we have set points for when to kick on another pump or what have you. But this is relatively new, even though we've been at it for, a decade. It is still new in the life of our treatment facilities.
Sorry, Jake. This is such an interesting conversation because it speaks to the open architecture nature of the approach and the ability to co-develop the strategy with each utility and take the approach that they want to take. OJ's mentioned the word black box at least a half a dozen times now, but in reality, all of the control logic in Buffalo was developed on an open architecture basis with the utility leadership, with their other consultants, which there are others involved, of course. And ultimately what gets deployed is a team effort. So I think, and there are utilities out there who are using both automation and human in the loop decision support system dashboards that provide situational awareness as well as recommendations and then other assets. And it's kind of an evolutionary process that you get to where it's like, okay, I don't need to keep clicking the button and establishing the set points manually. I can hand it over and just move into the supervisory oversight position.
Mm-hmm. Thanks, Tim. I guess with the two different approaches, and OJ, I'll start with you. Who's the ultimate custodian of this system? Is it a team of people? Is it one person? Kind of where does the buck stop with making sure the system's operating efficiently efficiently. There's, who's in charge of that feedback loop to make sure modifications are made or, changes are made within the system to make sure that it's optimized at all times.
That's an excellent question. We actually have a team of folks, kind of what we call it our three-headed monster. We, our engineering department, capital, the CapEx people, our maintenance division, right? And then our operations. So our heads of all the three departments actually come together to discuss, not only what's going up on the screen, but, hey, how are these things operating? How is everything working? How are the sensors working? What if we could change something, what will we change? And we come together during project development as well as post-project development to make sure that we're fine-tuning these as we get them on. No different than any other major capital projects that we would be delivering throughout our system.
Stacia, how about you?
Yeah, similar on our end. So the actual project keeper is a project manager within our treatment engineering group. And, they manage the day-to-day project activities, but when it comes to any decision-making points or any new task, it's actually a task order contract. So we issue a task at a time for the pieces and parts that we bite off and move forward with. We actually have a team that we pull into it, and it consists of our operations staff from each of our plants. It consists of actual engineering staff from other areas of our organization, including our modeling folks that actually are the keepers of our swim model, our system model overall. It integrates our integration team, which is actually the team of both internal and consultants staff that actually monitor our SCADA system and actually just keep up to date on all of our technology within our system overall. So the goal is to bring that's kind of the three, I guess, or four prongs that we bring into it. So we're all operating under consistent strategies with most up-to-date information and making decisions together as a team, because everything that we do touches each one of those aspects of our system overall. And we want to make sure everybody's in the loop on what it is we're doing and how we're doing it. And I mentioned recently, the plant actually suggested to our sewer maintenance center, our operations center, hey, you should consider using this for the flood wall. So we're actually starting to bring in, that aspect of our organization as well. But when it comes to the control structures in our system, our plants actually manage those. So when I say operations, we're bringing all the staff to the table that actually have the ability to, modulate anything in our system.
Okay, great. Let's see, we have about a minute or two left. I'll just throw one more question out there. OJ, at one point in your presentation, you talked about, cost per gallon of overflow. Is that kind of how you view your return on investment? I guess, what do you use that metric for?
Yeah, absolutely. We're looking at, just over a half a cent per gallon versus $3, $4, $5, $6 per gallon for some of our other, pieces that are in our plan and that are planned. Luckily for us, our plan as approved allows us to really add an adaptive management aspect of it. So we've been able to kind of drill down into some better opportunities for utilizing real-time control throughout our system, because we know that that's been the most cost-effective for us. So when we look on a return on investment, we look at efficiency for a city like Buffalo. That's exactly what we're doing. If we can solve the problem for cents on a dollar, that's where we're about.
Great. I know there are no other questions in the Q&A here. We're right up against time. Like Catherine said earlier, the link to the presentation is posted in the chat. Thanks again to all the presenters today.